I'll be talking about the 2010 Concepcion earthquake in Chile. About earthquakes, they occur when tectonic plates in the earth move around. The most severe earthquakes happen when the plates are moving towards one another. 75% of earthquakes happen within the Ring of Fire, which is where Chile is located, and the secondary waves cause the damage as they are transverse. About the Concepcion earthquake, it occurred on February 27th, 2010 at 3:34 local time. It lasted for over 3 minutes, which is very long. Normally earthquakes are only 1 to 2 minutes long. It was a magnitude 8.8, which is not the largest ever, but still an incredibly powerful earthquake. 2 million people were affected and 521 died, although some of those were due to the tsunami afterwards. There were over $30 billion lost in damages caused by the earthquake, and there were other environmental losses that can't be quantified. We used Altaria as a case study of a building that failed during Concepcion. It failed on the first floor, causing the building to overturn and topple completely. It was provided with reinforced concrete walls to resist lateral and vertical loads, but they were not sufficient to resist the seismic loading of Concepcion. 8 people died and 70 were rescued with injuries from this building, and 1 engineer was sent to prison for incompetence. In our first workshop, we attempted to construct a scale replica of Altaria. We decided on a 25 cm by 7.5 cm base to match the original dimensions of the building, scaling it down. We made columns stronger than beams, as the horizontal effect of an earthquake is far greater than the vertical, and we added cross bracing in all of the sections that could be included to try and add more stability and structural integrity under load, especially the more prominent horizontal loads. We were trying to construct a model such that its yield point was not exceeded by the force due to the earthquake. As you can see, due to the lack of time management, we could not realize these ideas in practice, but the theory behind them is still concrete. In our second workshop, we attempted to calculate the repose angle of a sandy material for different horizontal accelerations. We took dimension measurements of the sand before and after different accelerations to calculate the different angles the slope resumed after the earthquake. We plotted these angles against the acceleration to find the slope angle with a safety factor of 1.2 for the acceleration of Concepcion. In conclusion, it is clear that earthquakes cannot be prevented. However, through appropriate engineering techniques and applications, the effects they have can be limited and minimalized. Earthquakes do not kill people, but the damage they cause does. In this challenge, I've learned that some of these techniques and how they can be applied to real-life examples of engineering failures. Thank you for listening.